Hello, everyone. My name is Mohammed Saadi, and I'm a current senior with a biology degree at Oglethorpe University. The title of my presentation is How Wolves' Reintroduction to the Yellowstone National Park Stops a Trophic Cascade. So, my interest in wolves actually began last semester when I took a conservation biology course. And in that class, we read a book called American Wolf by Nate Blakesley. And it was a story that followed a wolf after the reintroduction to the Yellowstone National Park, and that wolf was named O6, and it was a true leader, and it had interesting characteristics like compassion that made me really interested in learning more about wolves, which essentially led me to this presentation. Before we dive in, let's go over a quick outline of where this presentation is taking. So I'm going to start off with a little bit of background slash history of wolves in the United States and how they came to this point. And then we're going to talk a little bit about the wolves' role in the environment and how they're essential. And then the wolves' introduction to the Yellowstone National Park. And then we're going to go over a study by Robert Bishta and William Ripple. And then we will wrap things up from there. And before we dive in further into this presentation, we should go over four words that if you fully understood, this presentation will become a lot easier. So the first word we have is trophic cascade. And this is an essential theme in this presentation. And a trophic cascade is a side effect when a trophic level of the ecosystem is either reduced or removed. Their ecological species interactions keep entire ecosystem balanced. So if you remove a predator from a food chain or a food web, there's a domino effect that goes down that food chain. So if you remove the top predator, whatever is under, it's gonna increase in population, and when that happens, everything that's under that is gonna decrease due to the overpopulation of the level above. So this shows how everything is interconnected, and like I mentioned, it's gonna be very important in this presentation. The next word we have up is ungulate browsers, and those are hoofed herbivorous mammals. And in our case, we're going to focus on elk and bison. The next word we have up is riparian plants, and those are grass-like form trees and other vegetations that grow along stream. And these plants are very important because they, one, control erosion, and two, they keep water clean and filtered. And last but not least, we have ecosystem, and that's a biological community of interacting organisms and their physical environment. All right, let's go over a quick history of wolves in the United States. So in the late 1800s and early 1900s, settlers started moving more towards the west. And as they did so, they took land and they turned it into farms with livestock. Because wolves ate some of these livestock, they slowly and gradually became the farmers' worst enemies. And that's when wolf hunting and poisoning began. So many wolves were shot and killed, and in some cases, they were even poisoned. Farmers would leave chunks of meat with poison out in different areas where wolves are located, and the wolves will eat these and end up dying. So in the 1930s, there were almost no wolves left other than this in any of the states other than Montana. And at the time, this wasn't really a big deal because a lot of the scientists and people in general haven't really understood the important role that wolves play in the ecosystem and their environments. And it wasn't until the 1970s that they started getting a little bit more attention, but even then, their population was continuously decreasing. It was the turning point was when they got added to the endangered species list, and that's when they started getting a little bit more attention and focus from scientists. And 15 years later, in 1995, 31 wolves were actually introduced to the Yellowstone National Park in an effort to protect and preserve these animals. So let's go to a little bit of the process of reintroduction and how things came about. So like I mentioned, in 1995, that's when the wolves were reintroduced to the Yellowstone National Park. And when they reintroduced these wolves, they actually kept them under watch so they could understand their behavior, ensure their safety, and can learn more about them. For some of the wolves, they were actually collared. What that means is that they had an actual collar device around their necks that kept track of their positions, and it also reported on some of their behavior. For the wolves that did not have the collar around their neck, they were watched by park personnel and with binoculars throughout the day. And actually, wolf watching became a full-time job for many of the park staff. So they would watch them daily and keep track of their behavior. And some of these park staff slash wolf watchers, they started developing relationship with these wolves, and this when they realized that wolves are more than just animals. Um, and so inside the park, hunting was actually prohibited. If somebody was to shoot a wolf or kill a wolf inside the park, it was considered a felony, and a lot of people were faced with sentences. Outside of the park, it depends on whether the wolves are at the time listed or removed from the endangered species. If they were on the endangered species list, then it was prohibited to hunt any of the wolves. But if they were not, then it was a fair game. And for the farmers outside of around the park area, if any of their livestock was eaten by wolves, they were compensated by the government. So you would think that since the main reason why wolves were removed from these areas in the first place was that they were eating the livestock of different farmers and they became their enemies, that now that the government is compensating these farmers with whatever they lose to these wolves, they would remove that hate towards the wolves. But that was not the case. People and farmers specifically around the area still hated wolves and wanted them gone. And it was actually considered an honorable status for somebody to shoot and kill a wolf. And some people were even voted for it. And in January of, as of January 2021, wolves are actually removed from the endangered species list. And so they are um, not protected by the government anymore. And most of the time, when, like I mentioned earlier, wolves were listed and re-enlisted from the endangered species, and almost every time this change was happening, it was never because of biological reasons, but rather politics. And when like for example, the last time they removed them from the endangered species, this evidence showed that they did not meet the requirement or the criteria for them to be off the list, but due to politics, they just removed them anyways. And this has been a controversial topic, and a lot of the U.S. courts have been going over it for many years. So in the years from 1935 to 1995, when wolves were removed from the park, species populations were affected differently. Because wolves fed on ungulate predator browsers like elk, when wolves were removed, this elk population started to grow increasingly. And the problem with that is because elk population was growing too large, whatever they ate was decreasing. And in this case, riparian plants were the victims of this equation. So what ended up happening is that the wolves were removed, the elk population grew, and in another scenario, the wolves were removed, and their competitors, coyotes, also grew, and this meant that whatever the coyotes fed on, which mainly was rats, including voles, these population also started getting hit by a major decrease. And to demonstrate this point, we have a food web right here from the Yellowstone National Park. So like I mentioned earlier, wolves are the main predators, so they sit on the top of that food web. And then right under you have the coyotes, which sometimes feed on elk, but they rather feed on voles. And then at the very bottom, you have the plants, which are eaten by most of these animals. So when you remove wolves from this equation, you have this elk population that start growing tremendously. And when that happens, whatever they eat, which is these plants, it starts to reduce, to be reduced dramatically as well. And then you have this coyote population, like I mentioned, when you remove their competitors, the wolves, then they start overfeeding on these voles, which will then be decreased. So this shows the interconnection of the ecosystem and the environment and how Every piece of this puzzle matters, and removing one will affect everything that goes under. And this actually leads me to a study by Pishta and Ripple, which was titled Recovering Riparian Plants Communities with Wolves in the Northern Yellowstone. And this was a study that focused on riparian plants and how their populations was affected by the removal and the reintroduction of wolves. And specifically, they focused on cottonwood and young willow plants. So when wolves were removed from the Yellowstone National Park around the 1930s, these plants were not able to grow more than 100 centimeters. And this led them to hypothesize that because when wolves were removed from the Yellowstone National Park, these plants were not able to grow more than 100 centimeters. Reintroducing wolves to the Yellowstone National Park should allow these populations to go back to what they used to be before. So let's go over a little bit of the method slash the way these authors tackled this study. So they focused on different areas of the Yellowstone National Park, and the areas consisted of two main regions, the Upper Gallatin and the Northern Range. And the Upper Gallatin was actually the area mainly outside of the park, and then the the Northern Range was the area mainly inside of the park. And specifically, they looked at areas around the Rose Creek, the Soda Creek, and the Lamar River. So in the Upper Gallatin, like I mentioned, because it's outside of the park, hunting, elk hunting specifically was always allowed. And that made the elk population in the Upper Gallatin of that area always lower than the Northern Range. But even though the elk population was lower there, the riparian plants were still suffering and they were not able to grow for more than 100 centimeters. In the Northern Range, area, the elk population was tremendously larger than the Upper Gallatin, and the riparian plants were even suffering more in that area. There was a time period when the park started practicing culling in order to reduce and control the elk population, and they were successful for a little bit in decreasing the elk population, but they were never successful to reduce it enough to where the riparian plants were able to grow for more than 100 centimeters. So the way they went about this is that they estimated the populations of wolves, elk, and the plants and bison. And the way they found the growth information about the for the plants is by creating 100-meter transects, and they measured the tallest tree plants in each area. And then they used linear regression to find trends in the spring and summer for the plants. And so let's start going over a little bit of the findings slash the results of this study. So here we have a graph that represents the population of bison and elk. And the way elk population is demonstrated is through the gray dots, and the bison population is represented through these white dots. And you can see the graph is split into two parts, and the upper part represents the Upper Gallatin area, and the lower part represents the Northern Range. So in the upper Gallatin area, you can see that you only see the gray dots, which, like I mentioned, represents the elk population, and there's no white dots up here. That's because there was no bison population in the Upper Gallatin, and only elks were found in that area. And here you can see both, and then how they relate. Also, the x-axis of this graph is the years for both the lower and the upper graph, and the y-axis for the Upper Gallatin area is the elk population. Now for the Northern Range in the lower part of the graph, you can see that there's two y-axes, and on the left you have the elk population, and on the right you have the population of the bison. So, another thing is that the graph is kind of split into two halves. So on the left side, you have wolves absence, and on the right side, you have wolves presence. So in the Upper Gallatin, you can see that the elk population was around 3,000 before when wolves were absent. And then when wolves were reintroduced, you see a dramatic decrease instantly to about 1,000, where it stayed consistently throughout the years. Now for the northern range, they have more data that goes further back. So you can see that around 1987, the elk population was almost at its peak of 19,000. And right here, even before the wolves introduction, you can see a huge decrease of that population. And this area right here represents the culling that I mentioned earlier. So that's when the park started eliminating some of the elk in order to control its population. But even then, it only reached about 12,000 elk, and it was too large, like I mentioned, for the riparian plants to grow. And so when they stopped that culling, you can see that the population went right back up to its peak of around 19,000. And when wolves were reintroduced, you can see a dramatic decrease and a continuous decrease until it reached a minimum of 6,000 uh, elks in about 2006. Now, the bison results were actually interesting. Before the wolf reintroduction in their absence, you can see that it was consistent around 600 to 800 bisons, and it stayed around that range for a little bit until wolves were actually introduced. Then the population started to increase. Now, in the paper, they don't have a clear explanation to why this happened, but one possible explanation is that because bison are competitors with elk for different riparian plants, bringing the elk population down should increase the bison population due to, like I mentioned, that competition. And obviously, wolves did not prefer bison over elk, and in fact, it took almost an entire pack of wolves to hunt down one bison because of their size. So because wolves preferred eating the elk over the bison, this allowed for the bison population to grow, and it reached a maximum of 1,700s in 2006. Now, something important to mention is that even though the bison population reached its peak around 2006, it was still only 1,700s, whereas even in the minimum point that the elk population reached, it was still around 6,000. So that's why in this paper, they mainly accounted for the elk, because no matter how much the bison population grows, it will never be able to catch that elk population. Here we have another graph, and this time it's focusing on the frequency of cottonwood trees. Um, and the graph is actually the opposite. It has an opposite setup of the previous one. So on the left now you have wolf presence, and then for this short period of time you have wolf's absence, and then you have wolf presence in that final bit right here. And this dashed line right here shows an exponential relationship between the riparian plants and wolf presence. As you can see, when the wolf were present, these plants were continuously growing and had an exponential growth until around the time periods of the 1930s when wolves were removed, and then they start taking a dramatic decrease until they literally reached zero. And then when wolves were reintroduced, the population went right back up to the normal levels. And like I mentioned, the x-axis right here represents the establishment decades and the years in which wolves were present or absent. And then on the y-axis, you have the number of trees. And so let's go a little bit of a quick summary slash main points of this presentation. So first of all, we have to mention that gray wolves are the most significant predators in the Northern Hemisphere. And there are a lot of studies like the one we talked about, along many others that prove this point, and that wolves are extremely important predators, and removing them means that the ecosystem slash the environment that they're in will go through major suffering, and populations of different plants will um, be the victims of this removal. Next, we have to mention that even though this whole history of the Yellowstone National Park, including the wolves removal and reintroduction, it came out to be fortunate, even though it was never planned to. But scientists ended up learning a lot about these wolves and different predator and prey relationship through this whole reintroduction of wolves. And next we have that predation risk drove elk away from the cottonwood and willow young um, plants. And this right here is very important because it supports the hypothesis of Ripple and Pishta in that removing the wolves will decrease the riparian plant population, but reintroducing them will reduce the elk population, which in turn will increase the riparian population. And then given that all of these facts and studies are taking place, someone will think that there isn't as much wolf hate that goes around in those areas anymore. But in fact, there's a lot of people that still want wolves gone, unfortunately. And it is on scientists to highlight different studies like the one we talked about in order for everyone to understand the full important role that wolves play in these environments and how if you get rid of these wolves, everyone will suffer in that ecosystem. And that brings me to the end of my presentation. If you guys have any questions, comments, or concerns, feel free to type it up in the comment section and I will try to respond to it. And lastly, I just want to give a quick thank you to Dr. Bobby. It's been a great semester and I ended up learning a lot of things. And thank you for allowing me to present on this topic that I'm really interested in. And I would also like to thank Dr. Donnelly for helping me put this presentation together. And last but not least, thank you guys for watching.